Here we're classifying as a monomial, binomial, trinomial, or not a polynomial. And we're also going to state the degree of the polynomial. So on part A, we've only got one term. One term matches up with monomial. The degree is the sum of the exponents on the variables. There's only one exponent, and it's a 1, so the degree is 1. I should say that again. The degree of a single term is the sum of the exponents. Part B, we've got 1, 2, 3 terms. Terms are separated by addition or subtraction. So this fits a trinomial. And then we'll look at the degree. The degree of the first term is 3. Degree of the second term is 2. Degree of the last term is 1. The degree of a polynomial is the highest degree of any single term. So the degree here is 3. Part C, we've got 1, 2 terms, so that fits a binomial. The degree of the polynomial is the highest degree of any single term. The degree of the terms is the sum of the exponents. So for this first term, 2 plus 3 gives us 5 for the degree. And the degree of the second one is 1, so the degree of the polynomial is 5. And in part D, if you have a variable exponent, it's not a polynomial. If you have a negative exponent, it's not a polynomial. Fraction exponent, not a polynomial. If it's not a polynomial, we don't have to worry about degree. Here we're writing it in standard form. Standard form is also known as descending order. Highest exponent to the lowest. So the first term needs to be the 3x to the 6, because that's the highest exponent. Next term needs to be the 9x squared, because that's the next highest exponent. And then finally we'll have that negative 4x. The leading coefficient, LC for short, is the coefficient of the first term when it's in descending order. So the leading coefficient here is 3. All right, for this next one, the highest exponent is 5, so that needs to lead off. Next we have exponent of 3, followed by an exponent of 1, and then a constant is considered to have an exponent of 0 for the variable. Leading coefficient, coefficient of the first term here is negative 7. All right, to find the sum or difference, we're going to add or subtract like terms. When we're adding, we'll just look for like terms and combine them. The coefficients get added together. 7 plus 5 is 12. And the variables to the exponents stay the same. Next, we see 2y plus negative 4y. That's negative 2y. And then finally, our constant, negative 3 plus 2 is negative 1. We have added those polynomials together. Again, we can only combine like terms, so look for the like terms. We're adding, so 4x squared plus negative 7x squared is negative 3x squared. Notice that I'm putting it in standard form as I go. Highest to lowest exponent. Negative 2x plus negative 3x is negative 5x. 7 plus negative 9 is negative 2. I'm going to show you one other way you can do it vertically. So I'm just going to rewrite so this is an alternate way of doing it. I'm going to write the first polynomial in standard form. Then when I write the second one, I'm going to write it so that like terms are lined up. Now you can add these together, and you're keeping like terms together. So 4x squared plus negative 7x squared is negative 3x squared. Negative 2x plus negative 3x is negative 5x. 7 plus negative 9 is negative 2. So if you want to do that vertical method, you're welcome to. It's easy to keep your like terms together. It's a nice way to organize them. All right. When you see subtraction, you can either go to the subtraction every single time, or you can think of it as a negative 1 and distribute. Change every sign, and then combine like terms. And so that's the way that students seem to make less mistakes. So I'm going to do it that way. So distributing negative 1 times negative 2x is positive 2x. Negative 1 times 5 is negative 5. Negative 1 times negative 7x squared is positive 7x squared. Now we're combining like terms. 3x squared plus 7x squared is 10x squared. Negative 5x plus 2x is negative 3x. Negative 9 plus negative 5 is negative 14. So once you distribute that negative, you can treat it as addition. Same thing here, distribute the negative. That changes every sign on the second polynomial. First polynomial stays the same. Combine like terms. So there's no other n cubes. Next we'll see 6n squared plus negative 5n squared, positive 1n squared, or just n squared. 2n plus negative 4n is negative 2n. And then finally this constant will be at the end. No other constant to combine it with. We've combined all our like terms, so we're done.